Good morning, everybody. Welcome to the webinar. So my name is Kurt Chan. I'm with ANSYS. I focus on our Discovery product lines, which consists of Space Claim, Discovery Live, and Discovery AIM. And I'm joined today by the wonderful KETIV application engineering team. And they're going to go ahead and introduce themselves. We'll start with John.
I'm John Dao. I go by JD. I'm one of the structural specialties, and I specialize in ANSYS here at KETIV.
My name is Nikhil Venkat. I am an application engineer here specializing in finite element analysis, CFD, and injection molding.
Hi, my name is Niyati Chokshi. I'm here as an application engineer for computational fluid dynamics in ANSYS division.
Fantastic. So with that said, you're hearing about KETIV, and I think it's really important for you guys to understand why you should invest in KETIV. Nikhil, can you share a little bit about KETIV?
Sure, thanks, Kurt. Again, my name is Nikhil Venkat, and as I said, I specialize in finite element analysis, computational fluid dynamics, and injection molding. Now, the goal of today's session, today's webinar, is to make all of you successful in your industries, right? That's our goal here at KETIV. We are really big on sharing knowledge and empowering the innovators and the manufacturers of today to be successful in the future and to become leaders in your industries. So over the next 45 minutes or so, we will be going over a great overview of simulation. And during the course of the webinar, if you have any question that you think of, please feel free to ask us that question. You can type it into the chat window, into the Q&A section, I believe. And we'll try and answer your questions as best as possible. If we cannot get to them, then we will definitely take them offline and get back to you.
Awesome. Well, fantastic. Thank you. One thing to keep in mind, again, for all the people that are joining, we're still seeing quite a people join a little bit late. This is a very minimal visual slides. This is more of a panel discussion. So definitely maximize your video screen so you can see our faces. And please ask questions in the panel. No question is a dumb question. Please ask them. We're here to address this. This is an intro to simulation. The biggest thing, looking at simulation, and I'm an engineer, all of us are engineers by trade, and specifically myself, I'm a CAD guy, right? I'm a designer, and that's one thing I love. When I've heard the term simulation, it's scary, right? It's scarier than like the Yeti monster to an engineer, because a lot of these engineers don't understand. A lot of us just feel that it's too complicated, right? Red means bad, blue means good. If that's how it is, if that's my result, we move on and we go give it to the analysts. Now they're going to go ahead and now run it and mesh it and figure out what needs to be changed and defeatured if they need to. But if we can do a lot of this upfront simulation, or I like to call simulation-led design, really quick, get our couple designs down and then move forward to the analyst, that's what some of our workflows are about. So we want to start with the basics, right? And, JD, I would love to let the people know, well, why should they really simulate, right?
Okay. So I'm actually really happy we have a lot of designers on the webinar today. My foundation and background was a design engineer for about 5 years before I became an engineering analyst. And, I always had the questions of, does my design work? I never really knew, right? And how does it impact my company? So the short answer to your question is it's really time and money. So Niyati, Nikhil, and I, we all come from different industries as well as you do, Kurt. And we were all responsible for the integrity of our designs, but we also had to manage a budget and our deadlines. So simulation, it allowed us to innovate while not sacrificing the quality and integrity of our designs.
I like that, and I like how you bring up innovation, because it's from a higher level, right? It's all about time and money. Okay, do we have enough budget? Okay, well, how much time is it going to take for you to do this? And sometimes that can stifle innovation when we start looking at the dollar amount and that time amount. Nikhil, can you share a little bit more about innovation and how that perceives and how that works together with simulation?
Sure. So let's take the example of the iPhone, right? With every release, the iPhone seems to be getting more powerful. It's getting lighter. It's getting more and more ergonomic, etc. Now, this was surely a result of multiple design iterations, and they analyzed all these multiple design iterations and then came up with the best one. Mm-hmm. Now, this is pretty much the bedrock of innovation, right? Trying to analyze different designs. And what simulation allows you to do is it pushes the limits of what's possible with design and with manufacturing. So what you're looking at on the screen is actually the evolution of the design of a drone using a technology called generative design in Fusion 360, in Autodesk Fusion 360. What generative design does is essentially optimize the design based on user input, user parameters like manufacturing process or what material you want to use. It allows you to evaluate all of these different factors all before a single prototype is built. So this is upfront simulation, as you were talking about, Kurt.
Mm-hmm.
And I think we have a question for from a user, I believe. Okay, we don't. All right, that's fine.
Well, so this is great. It's great to see some of this new technology, right, with simulation-led design, thinking about it from like generative design or topology optimization. And that's the beautiful part about what KETIV has to offer, right? You know, they resell a multitude of different packages here at KETIV, you know, from our ANSYS packages. So if you're looking into more of a topology optimization, leveraging generative, you know, they have real-time generative design with Discovery Live. That's all capable too. So there's multiple solutions you can go down when you're trying to figure out, hey, I want to go from a concept phase, or I want maybe an AI to give me an idea of an approach of, hey, look, the computer is giving me a design rather than me figure out how to design something based off locations and so forth. So, you know, we talk about the why, and that's always really important. But let's talk about the what and what really is simulation. So I'd love for you to share a little bit about what is simulation.
Thank you, Kurt. I would love to elaborate on that. So in a simple term, simulation is nothing, but it is a process of demonstrating and visualizing real life situations for different conditions. So here, I mean, what different conditions, it could be fluid flow, it could be vibration effects, it could be power generation, it could be stress on a small part or a product. Simulation is basically, it allows us to conduct studies for highly complicated mathematical and physics equations in a very, very user-friendly manner. And it also complements our CAD system. Yes.
So, you know, Niyati, you really mentioned about the breadth of what's going on. Yes. How about from a CAD perspective? Any perspective on CAD or the rest of the team here? Any perspective?
Yeah, so just, you know, I was a designer before, and I was CADing about 40 hours a day and also doing a lot of drafting. So we're familiar with the term CAD, a computer-aided design. So simulation, it actually has its own acronym. It's computer-aided engineering. So it's a tool that complements your CAD system. So as you're designing, you're also figuring out if it's working. It's not something that has to wait until the design's completed. It's something that works in tandem, and we can do both at the same time. So where CAD is your digital visualization of your design or your concepts, CAE or simulation, it's your digital visualization of the physics of your design. Like, how do I know it's going to work? Simulation is going to answer that question for you.
You know, I love both points here because you don't hear the term CAE often, right? All you hear is CAD, CAM, and sim, right? And sim is you hear that and people get scared of sim, right? Maybe we need to think more of this computer-aided engineering perspective.
Right, because it's aiding us.
It's aiding us. It's helping figure out the digital prototyping side of things. And that's the most impressive part that I love about simulation is that, you know, I'm a CAD and CAM guy, right? I understand manufacturing. A lot of us do as engineers. A lot of engineers know how to design, but then they don't know how to make really a lot of things, right? Some of them put, you know, square pockets that try to get machined, right? But this, we need to be exposed to these things, right? And if we use a part of like simulation, right, we can catch some of the digital prototyping things before we spend money on investing in prototyping right away. A big thing I like to talk about is, Nikhil, is who really does use simulation, right? Because we all know right away the perception is always going to be the analyst, right? But you look at 50% of the people on this webinar today are designers. And share with us what you guys come across in the industry and who the customers you guys work with, right? Because you're consultants, you're here to help make people successful. Share with us who should really be using simulation.
Well, who should be using it is, well, everybody, right? traditionally, simulation has been something that was a specialized tool set that only a certain small group of people in an organization, the analysts, had. Now, as much like this, the audience on this webinar, the vast majority of engineers in any company are designers and general engineers who wear multiple hats on most days. So what typically tended to happen is all of these designers would funnel their designs to the analyst every single iteration to have them validated, to have them analyzed. And that would lead to a lot of bottlenecks and also a lot of unnecessary work, right, for the analysts.
Right.
Now, imagine if we had products for designers. Imagine if we had something that designers can use easily. Well, we do. With advancements in technology, there are products now that are tailored specifically to designers, and there are products tailored specifically to analysts. Mm-hmm. So what designers can do, going back to what the previous slide, no, Jessica, if you can just go forward. So going back to what we were talking about previously, okay. If designers can answer these basic questions up front, right? So will my part break? Will it handle fluid pressure? What happens if the temperature changes? Mm-hmm. That sort of thing. Then the analysts can be focused, they can spend their time focusing on more complicated problems like systems. So how do parts interact? How is it going to behave within the entire system? Right?
Yeah. So I have like an interesting story to share. Like I came from a design background, 5 years of design, working at a company. We're trying to actually design a work cart that's going to service a monorail. And I was a designer, and we were trying to bid this project out. Very expensive. A lot of engineering service companies they were overbidding it because they didn't want to take the job. And I raised my hand and I said, hey, I have some simulation experience I just had in school, right? And I'm a designer, I understand, but I feel like I can do this. Mm-hmm. And I picked up the job, and within just about 6 months later, we had a design cart, electric service cart driving around our monorail system, servicing the monorail itself, the bus bars and everything. So, fantastic. That's how my simulation career started. It's just going from the designer and then just doing simulation, and now here I am today.
Mm-hmm. And I think a key point when we talk about the designer, right? Because once again, simulation is scary. That's what we all think about. And you look at the breadth of technology as technology has evolved, and we talk about simulation-led designers getting exposed to simulation, how we have different products for the analyst, like ANSYS Mechanical, ANSYS Fluid, right? When you want to refine that mesh, we have the product. And then if you want to get into more of like the design experience, right? Well, if I'm a designer, I don't know sim, but I'm going through multiple conceptual designs, and I want to just get an idea if I'm going on the right track, right? If my design is really going to hold up to X amount of weight, right? Because all designers here, we understand engineering in a fashion. We have products like that, like Discovery Live. You look at the instantaneous geometry, instantaneous change. You make a design change, the simulation updates instantaneously, right? Whether it's structural or even CFD, right? And I think that's the key part is people don't understand, and I'd love to hear you guys' input, is that really CFD is everywhere, because they think computational fluid dynamics, it has to deal with water, but really it's air too, right? Like gases, a fan turned on and it's blown across something, or natural convection, or any one of these things, it's still CFD. So if we can expose and educate people on CFD and then have a tool that can do it instantaneously, for example, like Discovery Live, right? And you have our other tools like, ANSYS Mechanical and Fluent. This just makes it more accessible, right? So Niyati, I'd love to hear your experience on that side too, if you can elaborate more. We heard from JD about his experience around, working at a company using analysis. We heard, from Nikhil around, who uses it, but what else are we missing out of this equation, you feel?
I would say as an analyst, analyst is very important, their point of view. So yes, computational fluid dynamics does not necessarily mean only fluids. That does not necessarily mean only water. It is highly acceptable in any situation which is fluid, in the sense I can use it in gas, different kind of gases. As an analyst, I would like to really emphasize on, we get loaded up with multiple kinds of design reviews we're supposed to go through, which costs us a lot of time. But I believe like adding simulation in an initial stage where designer can actually see what's happening, a very basic one, not a very high level. That's what we will do, high level, but a very basic one just to see, is it practical
Right.
to like change the design of this from a hexagon to a circle, something like that. It definitely eliminates a lot of time consumption and also helps us save money in a project if it is time-based. So as an analyst, I would say yes, including simulation in our initial stages is highly recommended. High-level complex equations, of course, we're there to do it. Yeah. But this will help the project and company like as a whole.
Yeah. Yes. Right, like Nichi's saying, usually the analyst gets very busy. What if you're the designer, you're trying to design a piston rod and I just want to know if my orifice is going to work, right? The shape of it.
That's true.
I have to wait weeks for it when I could really just do the simulation myself, change the geometry of my orifice, and I could see that, I'm getting the pressures I need out of it. So it's like really fast for the designer. Right?
So that the designers don't have to
so when they pass it on to the analyst, you're like, wow, good job. He actually, he came in with I didn't have to give a recommendation for orifice. He kind of knew. How did he know that? Because he's doing simulation himself.
And just to share with you guys too, so I started my career off at Northrop Grumman being a electromechanical engineer, and we used KETIV V5. And the interesting part was we're designing boxes for the JSF 35. And if I look back at the technology that we have today with instantaneous simulation, like with Discovery, if I could have just iterated really quick, got to like 2 designs and then gave it to my analyst to then say, hey, go ahead and do it, rather than be like, look, here's like 5 types.
Yes.
Go for it. And I look at the time. The goal here is we're not trying to take work away from the analyst. We want to make their life easier.
Right.
I mean, that's
it's complementing.
Yeah,
it's complementing for them.
It's gonna help designers too to stop retrading their work. If there's a very basic error, that has happened a lot of times with me. They give me, this is the final design. I think it's very good, and probably we're going to get good results. But there are like basic errors because of which I'm unable to mesh, unable to go ahead with the process. And I'm like, you need to change. So what they do is they have to go back, retrade the entire design they did with their hours of work, weeks of work, and there they go. And again, I tell them changes, and I'm like, you have to do the changes, but this process cuts down short. Yeah. And to add on to that, if you see Wright Brothers plane, if you see supersonic right now, the transition from there to the supersonic fighter jets to the comfortable commercial airplanes right now, all help simulation. It was all backed up by simulation. It reduced a lot of time, because if you see the new updated versions which come up, that's in a very short period, and that's probably because of simulation.
Right. The biggest thing too is that like simulation doesn't get enough recognition, right? Like as you see, they're pretty designed. You see the manufactured part, you get to touch and feel it, right? Yeah. But with simulation is that producer behind the scenes doing all that hard work of making sure everything will work on both sides. And our goal today is really to educate you guys on the importance. And speaking of the importance, we really emphasized and talked about what is simulation, who should use it, which is everybody. But when does simulation fit within the engineering process, right? Because people feel that they're still trying to understand where it really belongs. So I love to hear from everybody. Right. Let's start with JD. Share with us, where does it fit within this engineering process?
So that's a question that is very commonly asked. So where does simulation play a part in? The answer is really everywhere. So traditionally, simulation was only found in the engineering process. It was only found in the design phase, right? After you finish your design and then you simulate it, and you're going to see if it works. Yeah, exactly. But it can really fit everywhere. And Jessica, if you move next slide, what I mean everywhere is, what if you have to understand the environment and the parameters that your designs can exist in? How do you know your design requirements are satisfactory, right? What am I designing to? Simulation comes a role. That's simulation-led design, like Kurt was saying. Simulation-led design. I'm simulating before I even design. I understand the parameters and the environment, right? And now I have my my design requirements. They're pretty solid. It just leads to a better concept design. So what simulation helps us is coming up with stronger concept designs. I'm going through various different concepts with the design requirements I have with different parameters, and I'm verifying that this works.
Yeah.
And lastly, what happens if that design fails, or there's a product recall, or what if I just want to make it better? You know, like I'm pushing out the deadline, and we're going to come up with a better product next year, revision 2. Yeah. That's where simulation comes in play too. We get all the feedback and all the test data that we have, and we just come up with better products.
Yeah. And just to add on before we jump in is about that simulation-led design, right? I think on the previous slides earlier, you saw the generative design and topology optimization.
Right.
And, we offer so many, KETIV offers a lot of solutions and products, because you look at, like, for example, with ANSYS Discovery, the topology optimization, you can set loads and just say, hey, I need to have this part, this block here, is bolted down, and there's X amount of force. It's a block. Give me the right design to shave weight by 65%. And the software will do that for you. So this is your simulation-led design. Is you're saying, here's my piece of aluminum. Based off aluminum where it's fixed, give me the optimal part to hold the X amount of weight, right? So these are the things to think about as you start exploring into simulation of design, because a lot of us are just familiar with just designing something and then testing it. Design, then test. Where
design
we can
and test, design and test.
We can have an AI do it, and then have that work in parallel with everything else.
Right.
So I just wanted to jump in about that. But please, Nikhil.
Yep. So thank you. So as JD mentioned earlier, I come from the manufacturing industry. So in manufacturing and process, one of the things you learn is waste is expensive. So material cost can, depending on what you're trying to make, of course, material cost can run up to about 70% of all manufacturing costs, which is pretty high.
Quite significant. Yeah.
Quite significant, exactly. So if you were to, for example, have failures in the testing phase and you haven't tested anything before, you just blindly start testing with physical prototypes, it's most likely to fail. Statistically, it's most likely to fail. And that's also going to be a lot more expensive. Now, as JD said, think about that effect being pushed down further into the product development process. Say during manufacturing, you have a tooltip that fails, or because your material is too hard, or in the field you have failures. We're actually trying to help a customer that's having that very issue at the moment. So simulation really can it can help really alleviate a lot of the issues caused by not necessarily poor design, but also just design ideas that you didn't previously have.
Like if you could see the visual that we have up there, you see that curve, right? The red curve. It's very expensive to make changes at certain points in your engineering process, right? What we're trying to say is if you introduce simulation as a tool, that curve is going to just move down. It doesn't matter what stage it is. The changes for the figuring out the costs for the changes, it's going to go down with simulation. So it's just the time and money that we're talking about again. And
just so to be cautious of time, right? We're already at 10:30. We have a couple questions coming in, but this one really intrigued us. I would love to hear from the experts here, and for the people on attending, I'll share the question. So really, the question came in as this company, they have a conveyor system that has a section where four conveyors merge into one conveyor. Let's say they're moving at 300 feet a second, right? And they have a project in the works to improve the efficiency of these merging areas, right? To reduce the number of jams that will occur. So think about like UPS, right? And all this stuff coming together.
Okay.
Can what we do here, what you guys do here at KETIV, help solve this problem for this gentleman?
Yeah, so we have a lot of different tools that just go beyond your linear simulations that you're used to. We have like a lot of different dynamic tools. Like there's like Autodyne, LS-Dyna, ANSYS, and I'm sure Autodesk has some too, that where we could just simulate the movement of bodies, right? Rigid bodies kind of coming in and impacting, and we could probably try to simulate that.
Yeah. So the answer is yes. We can solve that problem. Awesome. Okay. Another question that came in is, what is the role of AI or artificial intelligence in simulation? So how does AI play a role in simulation?
I guess I could
All
just
right.
try to answer that one again,
Okay.
just because so there's different. I think Kurt was talking about the topology. I want to say that one's not very much in AI, but that's like a mathematical system to figure out loads and on optimization. But how does artificial intelligence fall in? Well, we actually have a company right now that is using one of the ANSYS tools to do autonomous vehicles, right? A lot of different errors and movements, random commands and running through different type of scenarios. And the artificial intelligence is just kind of running that. So like artificial intelligence right now, it's being used in different areas of simulation. And one of them I'm familiar with is autonomous vehicles.
Fantastic.
Right.
Yes.
Great.
If I can jump in there
Please.
with that
Please.
AI question. So one of the places that AI is actually being used is generative design.
Okay.
So generative design in conceptually what they're trying to do with it is have it mimic nature. So essentially it is trying to mimic the same processes that exist already in nature to build these products. It's using those same concepts. And so when you organically build something from the ground up, you would build it differently than you would if you were, say, doing subtractive manufacturing, right?
Right.
So that's where AI comes in because it is constantly learning. For example, let's say somebody builds something based off of something they see in nature. I can then use that same concept because the software itself has learned that, and it now has a new concept in its repository, I guess, to apply potentially to my problem.
So it sounds like it's giving us like the design, like the environment and parameters. It's kind of assisting us in different conditions. So our boundary conditions, I guess.
Like simulating the real life scenarios and helping us different conditions.
And just to finish up on this topic too, is that when we think about AI, we think about topology and generative, you know, the term, we're going to do a series around generative, right? Because people, you don't get it twisted around, well, oh, topology is different than generative. It's technically the engine behind it too, right? Generative just goes into a little bit more depending on what functionality you're looking for, right? But topology is a part of that. System. So technically, generative is the umbrella, topology is a part of that code system, right? I mean, as technology advances, we can think about manufacturing techniques, right? So if we design, one thing that's coming out with in the future with ANSYS Discovery is as we design for manufacturing, right? So hey, if I have a 5-axis CNC machine, give me a topology or give me a design to manufacture it on a 5-axis machine, right? And we have all these different opportunities. So so with that said, you know, we have another question coming in around how does simulation help with material selection, right? Because it's, you know, as an engineer, we're like, well, do I go with 70-75 aluminum or 60-61 or T6 or T4 based off what load? This is what I lived with at Northland, right? Like, pick one. I don't care. Aluminum's aluminum, right? But it's not, right? If you're on an aircraft, it matters, right? So how does simulation help us determine the right material to use?
You guys want to go with that one, and I could add my 2 cents afterwards? Or?
Sure.
Spend a minute on this, and then we'll get into our last and wrap up with some more questions. But bring in the questions, people.
Please feel free to add to that. So according to me, so material definitely makes a big difference. If you're talking about, as you said, aircrafts, anything in air, even a speck of paint hanging through the wing, it makes a very big difference. So when you're talking about material, we want to make sure our product usually is always either lighter or better manufactured, less wastage of material. That's where we can use, there's a product called Granta, which helps us in material selection. It has, it's by ANSYS, and there's a wide variety of material selection. I remember back in the days where if I had to get hold of any material property, I would have to either go buy a piece of paper.
Right, yeah, standard, an SAE, ASTM standard.
And that would give us an information, which would,
right.
and that would be just for one material, which I usually, if I'm in I was in a lot of research. So when I'm doing research, I want to make sure I have hands on a lot of other material properties. So one would be costing me a lot. Plus, yes, there is online which I can search, but statistically, it did not give me enough results or enough inputs that I can use for my simulation. But I've used Granta, and it is phenomenal. It has just wide variety available at your disposal for different kind of stresses, different kind of material, be it tungsten, be it aluminum,
its welding ability,
be it plastic, welding ability, yield strength.
Perfect.
Yes.
So ANSYS recently purchased the company Granta, which
Yes.
gives a fantastic product for material selection. It lets you compare different type of materials to just give you every property that you're curious about.
So another question came in around CAD. And as a designer, I'm sure we all use different types of CAD packages out there. I think one thing to keep in mind is, we have integrated solutions and then we have external solutions. Then we have solutions that just work hand in hand to where you click a button, it goes over, you can simulate and go back, right?
Yes.
It's all dependent on your cup of tea and what you want to accomplish. Talk about CAD and CAD and how simulation plays a role with CAD, and then how that workflow, because it's all about workflow as a designer. How does that workflow look?
Nikhil, you want to answer that one?
Sure. So, well, as a designer, there's a number of different products where your environment, your simulation environment, pretty much sits inside your CAD environment. It looks the same. It's in the same software. All you need to do is switch between different tabs in the same software, and your simulation environment looks familiar. There are other tools that help automate your simulation as well. So, for example, if you're running the same kind of simulation multiple times, there are ways to automate that, where all you need to do is say choose a new material or choose a new load or whatever that number is, right?
The parameterization kind of
Exactly
parameters.
And at the end of the day, this I think also ties back to the last question about why is material selection important. At the end of the day, if you can identify that a certain design works and is going to be 100% safe with aluminum, why would you want to use cast iron for that, right? Why would you want to make something heavier that's going to increase material costs, shipping costs, etc.? So essentially with your CAD system, going back to this question, for the designer, we have the same environment now. So the designer doesn't have to leave and send files to new software and start over.
No, and this is great, right? I know we want to be cautious of time here. We have a couple minutes left. A big thing is, one of the questions I had for the panel was, where can one do simulation? But we've talked about this, right? I think you've heard aerospace, you've heard about consumer products, you've heard about entertainment, right? You've heard all different areas, and this is where simulation, as we said, can be done by everyone across any type of industry, right?
Everyone and anyone, right?
Everyone and anyone. I think the last question that came up was expertise, right? Everybody is worried about, well, I have to be an expert to use simulation, right? And one of the taglines I love to use at ANSYS is, no expertise, experience, no problem, right? We have all different types of packages to fit your need, but what type of mathematics or math expertise do you really need to know to use simulation?
I could speak from the structural, for structural design. I think if you got a good understanding of just materials, like if you understand what a Young's modulus is, or a Poisson's ratio, or what is a tensile or the yield strength of a material, if you understand that, I feel very comfortable with saying that you can do simulation. And we offer a lot of our different webinars, and pretty soon one we're going to introduce is how does a designer understand the simulation results? And we're just going to break it down very easy for you. And that's something that we're developing, and I'd love to go over one of these days.
And just on this point too is JD is using some big words here, right? But if you know from how math fits in, if you know 2 + 2 = 4, you can do simulation, right? Because we have the products to help you out, whether it's the easy button like Discovery, or whether it's like you want to do some high-end CFD analysis with Fluent, right?
Yes.
We have the products, so don't feel that you need to know X amount. It is great to know that, right? As designers and as engineers, we've learned this von Mises, Bernoulli's equation, these big words, but technically we have any solution you want, and not just, I'm not a sales guy. I'm just telling you as an engineer to another designer that it's not what it used to be when I went to school and, when I was in industry, right? Even though I still am young, it's not the same, right? We have technology to help us out with that. So with that said, we appreciate all the interaction. We had over a dozen questions come in. We just picked a couple. Once again, our contact information is on the screen. I'm here with the KETIV application engineering team. My name is Kurt Chan with ANSYS. Please don't hesitate to reach out. Find us on LinkedIn. Love to connect. We're all throughout social media, and we're here to help you guys out be successful.
Yeah, we'd love to meet with you
Yes.
one-on-one. Let's discuss more of your
Yeah.
questions. I'd like to give you more answers.
Please reach out to the team here. Thank you again, everybody. And once again, we have other webinars coming up. Don't hesitate. Come to ketiv.com/simulation. Bookmark that so you know. Follow them on YouTube, right? Because if you're subscribed to their channel, you know when the next webinar will pop up and all that. So it's really important to keep engaged in the community.
We have more blogs coming up. We have some more blogs already listed. And just to let you guys know, we are very CAD agnostic, which is very important. And we are here to help you out. If you need any more help, or if you have more questions, we have our emails listed. You can contact us, reach out. We'd love to talk to you. And yes, to also add on, it's very easy. You don't have to have high level of mathematics or any kind of experience, but just the basics. And we are here to help you out. We are like an intersection of guidance, tools, resources. So if you're trying to do simulation, you cannot understand what your results are, we'll help you out.
Perfect.
So please feel free to reach out to us.
Cool. Well, thank you again for attending. We appreciate it. And if you want to watch the recording, it'll be back on YouTube. All right, guys.
Definitely.
All right.
Thank you.
Take care.